Hello there and welcome back to the Sleep Science. You're lying back, maybe on the edge of a wake and mostly cozy, watching a tiny point of light wobble across an old laptop screen like a moth that learned to read star charts. You probably won't survive this reality check. The sky keeps surprising you, and tonight it's doing so with a kind of quiet confidence that makes your brain tighten and yawn at the same time. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. If you like, drop your location and local time in the comments so I can imagine where you are as this story slides past. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You wake with the feeling that something has arrived. Not another comet with its predictable tail, but 3I/ATLAS, an interstellar visitor whose name sounds like a media outlet, and an ancient archive had a baby. You trudge out to the backyard telescope in your slippers, the grass still cool, and you see the slow, deliberate path it takes toward the sun. Unlike the first famous interstellar guest, Oumuamua, which scraped headlines in 2017 as a thin, cigar-like oddity, this object seems to be travelling with company. That fact, that interstellar objects are no longer solitary curiosities, is a mainstream historical fact now tucked into news cycles. Humans have previously spotted visitors from other star systems, and each one forced us to widen our mental borders. The companions first appear as faint, obedient fireflies in the Comet of ATLAS, tiny specks that keep pace, forming a pattern like beads on a cosmic necklace. You squint. You try different exposures on your camera. The dots are there across different filters and nights. They are not just sensor ghosts. Amateur feeds start to sync up, and what was once a murmur of curiosity becomes a steady chorus of images. You feel the small thrill that comes when many people point their eyes in the same direction. The same thrill that inspired early astronomers to crowd around telescopes in salons, except now the salons are Discord channels and late-night threads. Skepticism pins you down like a cozy blanket. Could these be artifacts? Cosmic rays, software glitches, satellites masquerading as mystery? You remember how Oumuamua's odd acceleration made some physicists propose solar radiation pressure as an explanation, and how others nervously suggested artificiality. That fringe tidbit, that an interstellar object could conceivably be a probe, or a sail, or something deliberately engineered, hovers at the edges of conversations whispered and smirked at, like someone in a coffee shop mentioning aliens and getting a friendly eye roll. Historians still argue whether certain early sightings were natural or misinterpreted. In much the same way, astronomers now debate how seriously to take these companion specks. You lean into the data. Professional observatories begin to chime in, long exposure stacks, astrometric plots, brightness curves that flicker like candlelight. The companions don't scatter randomly. They maintain formation, often rearranging as if performing a slow choreography. One night you see three cluster into a triangular formation. Another night a curved arc appears, as if someone traced a question mark in slow motion. You can't help but make three small jokes to keep your pulse reasonable. The fleet is trying out synchronized swimming. Maybe it's the universe's version of a flash mob. Perhaps they just wanted group photos for their starry Instagram. The humor eases the edge but doesn't explain the behavior. The solar approach changes everything. As Atlas inches closer to perihelion, solar radiation and tidal forces intensify. Nothing likes getting too close to the sun unless it has a very firm plan. Instruments designed to watch solar flares prepare for chaos, but the choreography continues. Companions clasp and unclasp positions, sometimes casting fleeting shadows that ripple across instrument feeds. You recall an obscure 1970s SETI note, a marginal footnote in a dusty proceedings volume, about companion clusters seen briefly on photographic plates and dismissed as plate flaws. You wonder, with a conspiratorial grin and a twinge of academic guilt, whether that footnote was a cautionary tale or an apology to future curiosity. Each image raises questions about shape and composition. Brightness variations hint at flat facets and sudden glints, geometry that seems purposeful. The light curves tease at edges and planes, and the rumour of engineering zooms back into the room like a polite but insistent guest. Still, formal debate hums in the background of every live stream. Is this debris catching sunlight, a swarm of related fragments, or, less comfortably, something with manufactured symmetry? Professional voices are careful, which makes you trust them a little more. Cautiousness is the astrophysicist's love language. By the time your tea goes cold, the social feed is a tapestry of wonder, snark, and careful equations. Citizen scientists upload calibrated stacks. Backyard telescopes produce frames that rival mid-tier observatories. The global network of curiosity tightens like an embrace. You watch as people give nicknames to individual companions, like parents to new, distant children. Dot 3, the question mark, little c. The naming is silly and human and immediately helpful. It makes the cosmos feel less like a lecture and more like a shared secret. And through it all, you realise you're not watching a single object anymore. You're watching an unhurried procession of possibilities, natural fragments thrown together by chance, a gravitational ballet, or something that chose to travel in company. Your pulse slows, not from sleepiness yet, but from the careful, consuming attention that comes when something in the sky refuses easy answers. You remind yourself to breathe, to savour the small certainties. Telescopes collect photons, people can coordinate observations, and the large mysteries, what chooses to cross star systems. Somewhere between skepticism and awe, you feel the first real tug of wonder, the slow, inexorable curiosity that will keep you awake in the best possible way as this fleet keeps moving inward. You're still staring at that faint smear of light on your screen when the next headline hits. Astronomers spot companion objects, following 3I/ATLAS-fleet or fluke. The words crawl across the ticker as if they're embarrassed to exist, and you lean closer, replaying the grainy footage from amateur observatories that now circle every science forum like campfire tales. The companions, those faint dots flanking ATLAS, move together with uncanny discipline. One frame shows them in a straight line, another in a soft curve, and the next night they appear to pivot around their leader like loyal satellites. It begins, as these things always do, with a blurry post. A backyard astronomer in New Zealand shares his stacked exposure of 3I/ATLAS, tagged with the kind of half-sarcastic caption that keeps online communities alive. Guess it brought friends. Within hours, other observers chime in, from Arizona, from Poland, from an Antarctic research outpost where the sky seems too cold for coincidences. Their images match. The pattern holds, the coordinates sync. Something is definitely there, and more unsettling, the somethings are moving in formation. You try to reason through the mundane explanations first. Satellites? No. Orbital paths don't line up. Debris caught in the same gravitational pocket? Possible, but the spacing feels too deliberate. Maybe instrument error, you tell yourself, though every updated frame mocks that theory. It's as if the universe suddenly decided to arrange a small parade and forgot to send out invitations. Historically, you remind yourself, cosmic anomalies have always inspired both scientific rigour and creative panic. Back in 1610, when Galileo first pointed his telescope at Jupiter and saw 4 tiny moons orbiting in lockstep, many refused to believe him. Some even accused him of smudging the lens to fake motion. The parallel isn't lost on you. Then, as now, the line between discovery and delusion is drawn with trembling hands. The images grow sharper as professional telescopes pivot toward the coordinates. The Vera Rubin Observatory releases a brief note acknowledging unusual photometric clustering near Atlas, written in that charmingly sterile tone scientists use when trying not to sound alarmed. But amateur sleuths on Reddit are less restrained. "Fleet confirmed," one thread declares, accompanied by shaky gifs and way too many alien emojis. You scroll through them, half amused, half spellbound. Someone overlays the companions' relative positions on an ancient naval diagram, as if to prove a cosmic formation strategy. Someone else claims the distances correspond to prime numbers, the favourite numerical bait of extraterrestrial conspiracy. It's absurd, and yet deep down you feel that prickling instinct that absurdity often precedes revelation. At your own modest telescope, you adjust the mount, squint through the eyepiece and catch it. A flicker that might just be your imagination, or a genuine reflection off one of the smaller companions. It pulses once, then steadies. Your breath fogs in the air and you laugh quietly at yourself for whispering hello under your breath. The data from professional observatories pours in over the next week. Analysts attempt to model trajectories, but the companions keep defying predictions. They neither spiral away nor collapse inward. They maintain fixed distances from 3I/ATLAS, as though tethered by invisible strings. Some scientists propose that they could be loosely bound fragments ejected from InterstellarObjects itself during a sublimation event, pieces of volatile ice and rock vented as it warms on approach to the Sun. That would make sense. Comets do shed material in dramatic bursts. But this arrangement, this geometric patience, remains suspiciously un-comet-like. There's a curious fringe theory that starts bubbling up from older academic corners, the coherent fragment hypothesis. It suggests that some interstellar bodies might contain self-organizing matter, clusters of magnetic minerals capable of aligning through long-range electromagnetic forces. It's unproven and controversial, the kind of idea mainstream journals treat like radioactive waste. Still, it offers an explanation that doesn't require extraterrestrial engineers, only exotic physics. Historians still argue whether earlier cometary anomalies, like the behaviour of comet Shoemaker-Levy 9 before it struck Jupiter, hinted at such coherent properties. While institutions debate, the internet does what it always does best, turns anxiety into entertainment. Memes bloom overnight, pixelated drawings of tiny starships escorting a glowing rock, jokes about space Uber convoys, captions like, "When your asteroid friends won't let you travel alone, you laugh at a few, then feel guilty for laughing, because somewhere behind the jokes are people staring at real data, trying to make sense of a sky that's misbehaving." NASA holds its breath. An internal email leaks, a terse acknowledgement that multiple stationary points have been verified in the object's field, pending confirmation of motion correlation. The phrase sounds bureaucratic enough to calm the public, but to those who read between the lines, it means they've seen the same thing you have and can't explain it either. A historical footnote drifts through your thoughts. In 1950, physicist Enrico Fermi famously asked, "Where is everybody?" during a lunchtime conversation about extraterrestrial life. The Fermi paradox has haunted astrophysics ever since. Tonight, as you sip reheated coffee and watch 3I/ATLAS glide through the darkness with its quiet entourage, you can't help but think, maybe the answer is right there, en route to the Sun. For now, the companions stay faint, teasing at the edge of detection. You adjust your exposure settings, careful not to oversaturate, and the points gleam like the tiniest sequins stitched onto the fabric of space. You think about the scale, millions of kilometers apart yet appearing close together from your perspective, a dance so slow it could lull you to sleep if not for the pulse of curiosity keeping you awake. You close your eyes for a moment, letting your mind drift. Maybe they're not ships, not fragments, not anything built or broken. Maybe they're just travellers from a far system, frozen seeds flung across interstellar tides. Or maybe they're nothing more than coincidence, nature's knack for geometry. But as your telescope hums softly, aligning with the stars, you suspect that coincidences aren't usually this patient or this pretty. You jot down a few notes in your logbook, brightness levels, timestamps, approximate separations. It feels comforting, anchoring wonder with numbers. You remind yourself that science begins with noticing, and tonight, noticing feels like a sacred act. The companions keep their quiet vigil around ATLAS, and you, a tiny human wrapped in blanket and disbelief, keep yours. The sky has always loved secrets, but this time, you think, it might be whispering in plural. You wake to chaos, not the apocalyptic kind, just the modern digital one. Endless pings, unread notifications, and a newsfeed melting under the combined heat of a science journalism and speculative panic. The mysterious companions of 3I/ATLAS have gone mainstream, and everyone, from astrophysicists to astrologers, wants a say. You rub your eyes, scroll through your screen, and realise that your quiet late-night observation has turned into a global guessing game. NASA's social accounts try to stay calm, ongoing analysis of 3I/ATLAS and associated bodies. No evidence of artificial behaviour, which is the bureaucratic equivalent of shouting, "We don't know, please chill." Predictably, the world does not chill. Within hours, every major outlet carries the story, and #Atlas Fleet trends above celebrity scandals and political drama. You see thumbnails of the same fuzzy dots from 10 different angles, all labelled mystery objects, each more clickbaity than the last. The first meme of the day shows the sun wearing sunglasses and saying, "Bring it on." You chuckle into your coffee. It's comforting. the way humour shields humans from the unknown, like wrapping existential dread in bubble wrap. Still, as you sip, something uneasy curls behind the laugh. A question about what it means when the cosmos starts looking back. Professional astronomers take to live streams trying to set the record straight. You tune into one hosted by a calm, dry-voiced physicist who sounds like he's narrating bedtime for nervous adults. He overlays orbit diagrams on a black backdrop, explaining how the supposed fleet might simply be debris moving in similar trajectories. Optical illusions of proximity are common in astrophotography, he assures the audience. The mind connects dots that may be separated by millions of kilometers. His logic feels sound, soothing even, until someone in the chat posts a new image showing the object's changing formation. You freeze. The data's from a Japanese observatory this time. Pristine resolution, minimal interference. The companions have rotated into a near-perfect pentagonal arc around ATLAS. 5 points, symmetrical. And then 2 frames later, the shape flexes, as though acknowledging its audience. Even the physicist pauses mid-sentence. He exhales softly, pushes his glasses up and says, "That is interesting." A few days later, a mainstream historical fact resurfaces in the news cycle. In 1910, when Halley's Comet passed by Earth, newspapers printed sensational claims that its tail contained cyanogen gas that would poison the planet. People panicked, bought gas masks and huddled indoors, yet nothing happened. The media frenzy around Atlas feels like déjà vu, the same restless dance between curiosity and fear. The difference is that now telescopes feed real-time data to the public, so every bright pixel becomes proof or prophecy, depending on who's narrating it. You join an online discussion group of citizen astronomers, a ragtag assembly of engineers, poets, retirees, and one over-caffeinated high schooler who seems to have hacked 3 observatories. The atmosphere alternates between laughter and awe. Someone jokes that the fleet is just space debris doing synchronized yoga. Someone else calculates possible relative velocities, posting charts that look like cosmic choreography notes. Through it all, you sense a strange unity, a collective heartbeat syncing across hemispheres. Then comes the viral clip. A 20-second time-lapse from an observatory in Chile shows one of the smaller companions flickering brighter than the rest, pulsing twice before dimming back into the background. That's all, 2 brief flashes. But they trigger every dormant fantasy of communication humanity has ever harbored. You tell yourself it's likely solar reflection, maybe rotation catching sunlight. But your brain, hardwired for patterns, whispers, 2 pulses, like an answer. Of course, the pseudoscientists arrive right on schedule. A popular fringe theorist posts a video claiming the objects are sentinel probes placed by ancient civilizations to monitor young planets. Another insists they're manifestations of higher dimensional physics leaking into visible space. Someone even revives a decades-old conspiracy about secret alien diplomacy. You scroll through it all, amused and exhausted, trying to hold the delicate middle ground between skepticism and wonder. In a quieter moment, you think about how each generation gets its own cosmic mystery. For your grandparents, it was the moon landing, proof that humans could reach beyond their cradle. For your parents, it was the Voyager Golden Record, humanity's message to the unknown. For you, maybe it's this, a string of silent companions riding a visitor from another star, a puzzle too elegant to dismiss. Historians still argue whether such mysteries reveal more about the universe or about the way humans tell stories to fill its silence. You go outside again, the night crisp and loud with crickets. Your telescope waits like a loyal dog. You aim it toward the coordinates, the faint signature of ATLAS gleaming low near the horizon. The companions are dimmer tonight, or maybe your eyes are just tired. You wonder if light years breed loneliness, if even comets need company for the long fall inward. The hum of electronics around you is soft and steady. Somewhere nearby, a streetlight buzzes. Somewhere far away, instruments record data that will take weeks to analyze. You lean against the railing, close your eyes, and feel small in the best possible way. The cosmos doesn't owe you an explanation, but it keeps offering invitations, and when you look again, the companions are still there. Faint, disciplined, patient as ever. Not menacing, not miraculous, just present. Watching or drifting, it's hard to tell the difference anymore. Your phone vibrates with yet another alert. someone's claiming to have decoded a message in the movement pattern. You groan, mutter something about people needing hobbies, and then, inevitably, click the link. Curiosity wins again, for now the fleet is still far from the sun, still far from certainty, and you're still awake, tracing light that left its home before humanity learned to read the sky. The panic has cooled a little, replaced by fascination. Whatever 3I/ATLAS is, whatever these companions become, you realize that mystery itself has gravity, and you've already fallen into its pull. By the time you open your eyes again, the world has shifted from jokes to data. Your social feeds have cooled, the flood of memes tapering into graphs, line plots, and exposure comparisons. The excitement has matured into curiosity, the best kind of collective insomnia. You, along with thousands of others, are learning a new language of light. You've joined a live stream from the European Southern Observatory, the kind that feels both formal and strangely intimate. The host, steady-voiced, coffee-warmed, explains how astronomers are chasing the data trail, untangling what's real from what's wishful thinking. On the screen behind her, ATLAS glides silently across a black grid, each pixel weighed down with information. She walks you through calibration, dark frames to remove electronic noise, flat fields to correct for uneven sensors, and bias frames that erase the subtle fingerprints of the cameras themselves. You didn't expect to find poetry in calibration, but here it is, a ritual of subtraction to reveal truth. Watching her align the data, you realize that astronomy is basically cosmic housekeeping, dusting away human error so that what remains belongs to the stars. Then come the overlays. New dots appear, blink, disappear, reappear. They're verified by different observatories, different continents, different nights. The pattern persists. The companions of 3I/ATLAS are not illusions. They are consistent sources moving together across time and telescope. A mainstream historical fact bubbles up from memory. In 1846, astronomers predicted the existence of Neptune purely from mathematical wobbles in Uranus's orbit. They pointed telescopes to where the math said the planet should be, and found it almost instantly. The discovery proved that unseen forces could be trusted to reveal visible truths. Now, nearly 2 centuries later, you're watching a similar process unfold, except this time, the math isn't quite matching. The trajectories of the companions don't behave like fragments. Their paths curve too neatly, their accelerations too synchronized. The data trail refuses to settle into natural randomness. It's as though something, gravity, magnetism, or perhaps intent, keeps pulling the pieces into formation. And yet, every new release from official channels keeps its poker face. No definitive evidence of coordination. You picture a row of tired scientists typing those words at 3 a.m., sipping cold coffee while their eyes flick to the same images that keep you awake. You can almost hear them muttering, "Please let it be ice." You try to help in your own small way. You download open-source data from the Las Cumbres network, a messy cloud of numbers that feels both thrilling and intimidating. After a few hours of squinting at pixel values, you manage to plot the faint motion of 2 companions relative to ATLAS. The lines on your screen trace a looping spiral, an elegant twist you can't quite fit into any simple orbital model. You screenshot it, post it to your astronomy group, and immediately get 3 reactions: a like, a correction, and someone insisting it's Morse code. To break the tension, you make yourself a snack and whisper, "Maybe the fleet just wants to spell LOL." The joke lands softly in the quiet kitchen air. Humor has become your coping mechanism for cosmic ambiguity. As the days pass, more institutions join the chase. Harvard's Minor Planet Center, the Max Planck Institute, even an observatory in India that usually tracks near-Earth asteroids. Each confirms sightings of the companions. Each measures slight but consistent shifts. A fringe tidbit circulates. A rumor that one companion shows spectral lines suggesting metallic reflection rather than icy dust. No official paper backs it up, but it catches fire anyway. Late one night, you tune into a Q&A where a planetary scientist discusses the possibilities. Her voice is gentle, practical. If these are indeed coherent fragments, she says, they could represent a type of interstellar debris we've never catalogued. Perhaps shards from a broken exoplanet, frozen metallic hydrogen, or even, she hesitates, something engineered, though we must tread carefully there. The live chat explodes. You can feel the collective breath of thousands leaning closer. Historians still argue whether our species ever truly learned patience in the face of the unknown. Tonight seems to prove that the answer is not yet. People demand explanations, certainty, closure. But you find a strange comfort in the not knowing. The trail of photons reaching your screen began its journey before recorded history. It can wait a little longer for understanding. Outside, the sky hums with late-night stillness. You step onto your porch, telescope cooling in the breeze, and glance upward. Somewhere out there, 3I/ATLAS, and its strange attendants carve slow arcs toward the inner solar system. You imagine them as glowing seeds riding invisible winds, each spinning gently, unaware of the drama they've caused on one small planet. You can't resist one last check. Through the eyepiece, you glimpse the faint streak again, so subtle it could vanish if you blinked. But the companions remain visible, faint pinpricks beside it. The data trail is no longer abstract. It's right there in your line of sight, patient and silent. You think about those early astronomers charting Neptune by faith in mathematics, and how even then some dismissed it as coincidence until the telescope proved them wrong. Maybe, you muse, history repeats not because the universe is predictable, but because wonder always follows the same path: disbelief, data, discovery, and then another mystery waiting just beyond the noise. You close your notebook, smile at your own shaky graphs, and whisper into the dark, "All right, little travellers, let's see where you're going next." The cosmos, of course, doesn't answer, but the faint light winks just once more before clouds roll in, as if acknowledging your persistence. Morning brings a strange calm, the kind that comes after every collective gasp. The public has moved from astonishment to obsession. Every telescope, every orbital camera, every stargazer with a tripod is now watching the same patch of sky, and all their eyes are telling the same story. The fleet is growing. You pull the curtains open and half expect to see it looming over the horizon like a slow invasion. But of course, it's still a few 100 million kilometers away, hidden in daylight and distance. You check the live dashboards, thin blue lines over dark backgrounds, graphs that look like the heartbeat of something enormous. Each new update adds a dot to the map. The fleet is no longer a handful of companions. There are dozens now, maybe more, each one keeping roughly the same spacing, each moving as though tethered by invisible geometry. You try to imagine the scale. If these objects are kilometers wide, they're dancing in formation across a stage larger than Earth's entire orbit. It's absurd, and yet the math refuses to laugh. Professional observatories release composite mosaics stitched from nights of exposure. You zoom in until the pixels crumble. The companions glimmer like metallic crumbs, faint but deliberate. Some are brighter than before, reflecting more sunlight, or perhaps unfurling something broad. You picture sails, then immediately tell yourself to stop picturing sails. Still, the thought sticks like glitter. Could sunlight itself be their engine? A mainstream historical fact surfaces to soothe you. In 1619, Johannes Kepler wrote letters describing how a thin sheet could, in theory, ride the pressure of sunlight across space. Centuries later, humans built LightSail 2 to prove him right. The idea isn't alien at all, it's ours. Maybe these companions are just nature's version, icy fragments flattened by sublimation, turned into accidental sails. That explanation should calm you, it almost does. But even natural sails don't explain the choreography. The latest trajectory plots look too deliberate. The spacing ratios remain near perfect. The brightness pulses match rotational periods, far too uniform for random debris. Your chat groups fill with diagrams of sacred geometry overlaid on star maps. It's half science, half sleep deprivation. You start keeping a small log beside your bed. Timestamps, magnitudes, quick sketches. The handwriting turns lazy by 3 a.m, but it feels good to participate, to turn awe into data. On the fourth night, you note a faint pattern. 5 companions that seem to pivot slightly around Atlas every 26 hours. Probably an illusion, you tell yourself, but it reminds you of the slow whirl of planets around a miniature sun. You laugh softly. Maybe they're just showing off. Somewhere between seriousness and silliness lives a rumour. An intern at ESA supposedly ran a curve-fitting algorithm on the motion data and found recurring harmonics, ratios that correspond to musical intervals. The leak spreads fast, a tune humming through conspiracy channels. Could the fleet be singing? The thought is ridiculous, poetic, and therefore irresistible. Historians still argue whether Pythagoras actually believed the heavens made literal music, but tonight the idea feels less metaphor and more invitation. You join a live stream from Hawaii. The host, a weary astrophysicist with a beach-tanned face and a sense of humour sharp enough to survive Reddit, explains that the expansion of visible companions might simply be a matter of sensitivity. Our instruments are improving faster than our explanations, he says, smiling faintly. Then he adds, "Of course, if they start waving, I'll let you know." You laugh along with the chat. It's the kind of dry levity that keeps wonder humane. After midnight, you go outside again. The air is crisp, the sky wide. You can't see Atlas with your naked eye, but knowing it's up there changes everything. It's like spotting a silhouette in a dark hallway, half comfort, half thrill. The world feels quietly alert, a planet holding its breath. You imagine ships passing silently between stars, guided not by engines but by patience. A breeze lifts your hair, cool and ordinary. You whisper, "If you're debris, you're the neatest debris I've ever seen." Somewhere above, radio telescopes listen too, collecting hiss and static, turning space into sound. You wonder if those recordings will someday reveal faint pulses, the kind that hint at encoded structure. You wonder what humanity would do if they did. The fleet continues to multiply in reports. 30 companions, 42, then 60. Analysts argue that the count might include reflections or paired objects splitting under solar stress. Others say the spacing is too controlled for breakup events. You feel like you're watching the universe write long division in slow motion. A quirky tidbit filters through one of the research blogs. A graduate student points out that the growing pattern of companions roughly traces the golden spiral if plotted in polar coordinates. No one takes it seriously, but the image goes viral anyway, Atlas at the centre, the fleet curling gracefully outward like a cosmic nautilus shell. You save the picture to your desktop because honestly, it's beautiful. The debate now has its own gravitational field. Some scientists begin to call the formation the Atlas cluster instead of fleet, trying to reclaim the narrative from tabloids. The phrase sounds calm, respectable, measurable, but everyone knows which word the public prefers. Fleet still trends higher, maybe because it suggests intent, movement with meaning, and people, yourself included, crave meaning. You close your laptop, letting the fan's hum blend with the night insects outside. The data graphs still glow behind your eyelids, those neat lines expanding, the little lights multiplying. You feel something between excitement and melancholy, the way you feel when a mystery grows instead of shrinking. You tell yourself that soon the sun will take over, burning away ambiguity with sheer light. The fleet will melt, fragment, reveal its secrets through spectroscopy and physics. But for now, before the heat and certainty arrive, you get to live in this rare moment of wondering. You lie back, counting invisible companions instead of sheep, letting their imagined rhythms slow your pulse. Somewhere, millions of kilometers away, a cluster of shining bodies drifts closer to the sun and closer to your dreams. The night you finally step back from the telescope, your neck sore and your patience thinner than moonlight, you realize you've spent weeks watching something that barely moves. Yet the stillness of 3I/ATLAS and its companions feels deceptive, like the long inhale before a story changes direction. The fleet has become background noise to your life. You track it between work meetings, over breakfast, during half-dreaming moments before bed. Somewhere in that repetition, fascination has turned into routine, and routine into reverence. You start reading everything you can about interstellar visitors. The phrase itself, interstellar visitor, feels like polite understatement, as though the cosmos is hosting a dinner party and forgot to mention it invited someone from another galaxy. You dig up the history. In 2017, astronomers spotted 1I/Oumuamua, the first confirmed object to enter our solar system from beyond. Its shape, long, thin, and tumbling, baffled scientists. It didn't behave like a comet or an asteroid, and it accelerated slightly as it left the sun, like something catching a faint breeze. Some said it was outgassing. Others quietly wondered whether it was a probe. Then, in 2019, came 2I/Borisov, a more traditional comet, all dust and ice, streaming a tail like an old movie's special effect. That one behaved itself, comforting, predictable, friendly to equations. So when 3I/ATLAS was first spotted, it should have been just another footnote in the catalogue. But now, with this fleet, it's rewriting the margins of astronomy. You scroll through archived reports. Historians still argue whether Oumuamua's odd acceleration was a quirk of radiation pressure or something engineered. The papers read like dueling lullabies, half of them murmuring reassurance, half whispering invitation. And now, with ATLAS, the arguments are louder but more refined, dressed in better data. One fringe tidbit catches your attention. An old Soviet paper from the 1980s speculating that interstellar bodies might occasionally travel in clusters, cosmic flotillas of debris born from the same ancient collision, drifting together for eons. The idea was dismissed then for lack of evidence, but you can't help thinking that someone somewhere is now digging that paper out of storage with a triumphant grin. The more you read, the more 3I/ATLAS feels like a sequel in a series the universe didn't tell us it was writing. Each visitor arrives with its own personality. Oumuamua was the mysterious stranger who left without a word. Borisov, the open-book traveller who showed us the ordinary beauty of alien ice. And now Atlas, accompanied, deliberate, a guest who refuses to travel alone. You pour another cup of tea and imagine these objects as breadcrumbs along a galactic trail, hints of civilizations or cosmic coincidences that happen just often enough to keep us awake. If comets are time capsules of their home systems, then these interstellar ones are postcards from across light years, each carrying fragments of chemistry, structure and motion that don't belong here but now orbit within our reach. The professional updates keep coming, and with them, cautious wonder. Observatories report that the companions' orbits share a near-identical inclination, tilted by 30 degrees to the ecliptic. That's unusual, but not impossible. Still, the alignment makes you squint. Nature is messy. This looks curated. You imagine scientists leaning over data tables, murmuring the same thought but not daring to voice it on record. It's probably nothing, they say, and everyone nods because no one wants to be the next person mocked for saying aliens. But you can sense the collective itch, curiosity restrained by professionalism. Meanwhile, the online citizen science communities continue to blossom. People start naming the companions after mythological attendants. Atlas's burdened stars, Percy, Merope, Aegle, Hesperus. Someone compiles them into a digital atlas, the lowercase kind, mapping their coordinates with affectionate precision. You add your own notes, faint magnitude changes, speculations in parentheses, doodles of imagined shapes. You know you're not helping the data much, but you are helping yourself to a small piece of belonging. Late one night you dream that you're standing inside a vast dome of glass, and above you the fleet drifts like lanterns released into the dark. In the dream, they speak. Not in words, but in rhythm, a soft harmonic pulse that feels like breath. When you wake, your clock is blinking 3:03 a.m, and the fan hum sounds suspiciously like that same rhythm. You smile into the darkness. "Nice trick," you whisper. By now, public interest has peaked. Documentaries are being pitched. Streaming platforms compete for exclusive telescope footage. You half expect to see the fleet's trajectory plotted next to movie release dates. Someone even releases a lo-fi remix using the companion data as MIDI notes. It's soothing, eerie, and weirdly catchy. You listen to it on loop while editing your observation logs. Amid the buzz, one verified report slips quietly through. Spectral analysis from the James Webb Telescope detects faint absorption features, carbon chains unlike any seen in typical comets. The finding is labelled preliminary, but it sparks long threads about interstellar chemistry. You picture organic molecules hitching rides across the galaxy, like spores on the wind. If they survive their close brush with the sun, they could seed another system someday. Life, or at least the rumour of it, travelling by convoy. You step outside again, tracing constellations while your eyes adjust. Somewhere up there, the fleet inches closer to the inner system, its paths braided like silk. You think of all the observers, amateurs, professionals, dreamers, each watching from their corner of Earth. From this distance, the sky doesn't care who's accredited, it just shines. A soft breeze moves through the trees, rustling leaves like a low applause. You imagine it's for the universe, performing one of its oldest acts, showing off just enough to make sure you keep watching. You grin and whisper to the darkness, "Fine, you win, I'll stay awake." The world has now entered what one news anchor calls the era of solar suspense. Every headline circles the same enigma, 3I/ATLAS, and the cluster around it are nearing the Sun, and the data are turning slippery. The closer the objects get to the inner solar system, the harder they are to track. Instruments saturate, signals bend through heat and glare. You refresh the feeds every few hours, watching lines of numbers blur like mirages. It's as though the sky itself is trying to hide its secrets behind sunlight. Scientists start talking about solar winds, the invisible gale of charged particles forever flowing outward from our star. These winds can push on small surfaces, scatter dust tails, and twist trajectories like ribbons in a hurricane. A sensible explanation, you think. Perhaps the companions are nothing more than light debris caught in radiation pressure, their coordination an illusion created by physics and perspective. The solar wind becomes everyone's favourite scapegoat, a polite way of saying, we don't know, but at least it sounds natural. You tune into a live stream from the Solar Dynamics Observatory. The host, a cheerful engineer wearing a hoodie emblazoned with a cartoon sun, explains how sunlight itself exerts measurable pressure, tiny but persistent. He compares it to a cosmic hairdryer, constantly blowing on everything nearby. Even an aluminum sail the size of a city block could feel that push, he says, smiling. You imagine those companions glinting in the brightness, like sequins riding a solar breeze. Still, not everyone buys it. A quieter camp of astronomers notes that the fleet's trajectories are too stable. Solar radiation should cause subtle drifts and spirals, yet the companions keep near-perfect spacing. If they're debris, one astrophysicist tweets, they're the tidiest debris in the galaxy. The tweet racks up 250,000 likes and 1,000 conspiracy threads. You lean back in your chair, grinning. The debates have reached that beautiful stage where both sides make good points and neither can sleep. Historians still argue whether such arguments drive science forward or simply make better bedtime stories. Either way, you're grateful. They keep your nights interesting. A quirky tidbit emerges from a French observatory's blog. Their eye pattern recognition software, trained to flag instrumental errors, keeps labeling the companions as objects of interest, non-random coherent reflectors. The machine doesn't know poetry, but its phrasing sounds almost romantic. Someone on social media quotes it over a photo of the fleet and captions it, "Non-random coherent reflectors, my new band name." Beneath the humour, though, you sense unease. The models that predict comet fragmentation show jagged orbits, tumbling chaos. What's happening around Atlas doesn't match. You visualise invisible forces, magnetism, charged plasma, maybe even electromagnetic tethering, playing marionette with the objects. You read about flux ropes and interplanetary magnetic fields, about how solar storms can twist themselves into knots big enough to swallow worlds. The vocabulary alone feels like a lullaby of power. Chronal loops, reconnection events, plasma sheets. Then, late one evening, a live feed from NASA's Solar and Heliospheric Observatory catches something subtle. As Atlas inches closer to the Sun, faint arcs of glowing plasma flicker near several companions, brief as camera flashes. At first you assume it's artifact noise, but the frames repeat across instruments. Solar wind interaction, one caption claims. Another says, possible charge exchange glow. But the way the arcs curve, graceful, deliberate, gives you goosebumps. You pause the footage, zoom in until the pixels break apart. Each flare looks like a filament connecting the companions, thin and almost translucent. Maybe it's just ionized gas tracing magnetic fields. Maybe it's a glimpse of invisible architecture. You rub your eyes, unsure which possibility feels stranger. A historical fact floats through your drowsy mind. In 1859, the Carrington event unleashed a solar storm so powerful it set telegraph wires on fire and painted auroras across the Caribbean. If the sun could do that to 19th century wires, what might it do to a cluster of objects diving toward it now? The thought is both thrilling and terrifying. A celestial chemistry experiment you didn't sign up for but can't look away from. Online, the tone shifts. Theories of alien fleets give way to discussions of solar physics. The internet has discovered magnetohydrodynamics, and suddenly everyone's an expert. Diagrams bloom across feeds like digital dandelions. You scroll past them half smiling, half impressed. For once, humanity is arguing passionately about plasma instead of politics. Maybe the fleet is doing us a favour. Still, there's an odd coincidence that keeps you awake. The companions' arrangement appears to resist solar wind models. Instead of scattering outward, they tighten their formation as they approach perihelion, as if bracing for the gale. Some observers describe a faint rotation among them, a synchronized tilt toward the sun. The data are noisy, but the pattern feels real enough to raise eyebrows. You step outside to clear your head. The night smells like rain and static. You close your eyes and imagine the fleet carving through invisible currents, their paths bending and shimmering in heat. Perhaps they are just rocks sculpted by light, yet part of you wonders if they know what's coming, the onslaught of energy waiting to test their resilience. A single drop of rain lands on your cheek, cold and grounding. Solar winds and secrets, you murmur, smiling at your own melodrama. Then you remember that somewhere above the clouds, those companions are actually enduring winds strong enough to strip atmospheres from planets. You feel suddenly small and somehow honoured to witness even the faint reflection of that violence. Back inside, you jot one final note before bed. Fleet maintaining coherence, radiation pressure insufficient, something guiding or binding them. You underline the last phrase twice, then add a question mark. That's all the universe ever gives, really. Question marks handed down through light. You drift off, imagining the companions gliding through solar gusts like surfers on invisible waves, each trail of plasma a ribbon tying them together. Maybe they're just debris dancing by chance. Maybe they're pieces of the same ancient craft refusing to drift apart. Either way, they're holding formation against the sun, and that, you think before sleep takes you, is worth staying awake for. The first rumour comes from a retired radio astronomer in Sweden, who still monitors old SETI frequencies for nostalgia's sake. He posts on an obscure forum, claiming he's detected a strange interference pattern timed precisely with the passage of 3 I/ATLAS near the Sun. The signal isn't a message, he says, just an oddly regular oscillation, like the heartbeat of static. Most users dismiss it as wishful listening, but the post travels fast, pulled into the gravity well of curiosity that now surrounds the mysterious fleet. Within a day, amateur sleuths are digging through archives searching for precedents. That's when you stumble across something peculiar yourself, a scanned article from 1976, buried deep in a digitized SETI newsletter titled On the Occurrence of Companion Clusters in Deep Field Observations. The author, a Dr. Miriam Alcott, a name unfamiliar to you, describes faint symmetrical point groupings seen near a passing comet, likely photographic artifacts. Still, she writes, if verified, such arrangements might represent directed motion inconsistent with stochastic distribution. You blink. The phrasing sounds eerily modern, a fringe tidbit indeed, one nobody took seriously. The paper ends with a line that feels almost prophetic. Should we observe such coordination again, I suspect it will not be the last time. You lean back, the room dim except for the glow of your monitor, and whisper, well, Dr. Alcott, looks like you were early to the party. You decide to dig deeper. The next few nights are a blur of online archives and faded PDFs. You find that Alcott's notes mention cluster echoes, recorded by a defunct radio array in Arizona, strange blips that repeated at 24-hour intervals. At the time, they were blamed on ground interference from power lines. Yet, coincidentally, or perhaps inconveniently, they occurred the same week a minor comet, C/1976 R1, passed close to the Sun. Historians still argue whether those anomalies were technical errors or the first glimpses of something more deliberate. You rub your eyes, half expecting to find nothing but coincidence. And maybe that's all it is. Parallel weirdness separated by decades. Still, you can't shake the sense that somewhere between the paper grain and the radio hiss is a whisper that's waited half a century to be heard again. Meanwhile, the chatter around 3I/ATLAS intensifies. Mainstream outlets keep a safe distance from words like fleet and message, preferring phenomenon and unexplained clustering. But scientists are privately intrigued. A leaked memo from an ESA internal meeting refers to patterns reminiscent of controlled vector drift, an expression so cautious it practically wears a lab coat. The leak hits social media within hours, of course, and the phrase controlled drift becomes the internet's new favourite euphemism for we're freaking out but scientifically. You tune in to a late-night roundtable discussion among researchers and historians. One older physicist recalls the WOW signal of 1977. The famous 72-second burst that SETI detected and never heard again. If we'd had today's instruments, he muses, maybe we'd have known if it came from something like this. He gestures toward a projection of 3 I/ATLAS, glowing faintly beside the sun. History has a way of leaving us breadcrumbs in static. You jot that line down, it feels important, poetic. Then, because you can't help yourself, you open the SETI public database and scroll through live readings. The graphs are mostly noise, cosmic microwave hiss, terrestrial interference, satellites pinging home. But once, just once, you spot a faint rhythmic modulation, a barely perceptible uptick repeating every few seconds. You screenshot it, heart racing, though you know full well it's probably nothing. You whisper into the dim room, if you're out there, you have terrible timing. The fan hum answers for the cosmos, as always. Then, as if in response, new imagery surfaces. A consortium of universities releases long exposure data showing faint filamentary connections between several companions, threads of light that might be dust tails or ion trails, but which align with uncanny precision. A few speculative researchers compare them to antennae. Solar sails often double as communication structures, one article suggests before being quietly taken down. The whispers from the old archives suddenly feel louder. You picture Dr. Alcott in the 1970s, squinting at grainy telescope plates under fluorescent light, noticing the same patterns you see now, and perhaps feeling the same chill of recognition. Late that night, you go outside with a small radio receiver, more for symbolism than science. You tune it to an unused frequency, static pouring out like crushed stars. Somewhere high above, solar radiation storms dance and the fleet glides closer to the sun, invisible against daylight but alive in your mind. You sit there in the dark, wrapped in a blanket, and imagine that faint hiss as a kind of dialogue. It's ridiculous, you know. You're not going to intercept messages from interstellar travelers on an old AM radio, but the ritual matters, the act of listening. The world is always louder when you stop pretending it's silent. Before heading inside, you glance at the horizon, where dawn is smudging grey across the sky. The air feels charged, as if even the atmosphere is holding its breath. You remember that ancient myth, where the gods sent comets as messengers, their tails the scripts of divine intent. You smile. Humans have always looked upward and seen handwriting. You close your eyes and imagine the fleet suspended there. The companions humming softly in solar wind, their motions spelling something too vast and slow for your brief senses to decode. You don't need to understand it tonight. It's enough to know that you're part of the long tradition of watchers, those who, across centuries, have mistaken coincidence for conversation and found wonder in the error. Back inside, you pull up your observation log and type a new entry. Found Dr. Alcott's 1976 paper, mentions clusters, radio echoes, feels relevant. Wonder if she ever realized what she'd seen. You pause, then add sometimes history whispers twice before it shouts. When you hit save, a faint pop of static from your receiver fills the silence. Just interference, almost certainly. But it sounds, just for a second, like someone exhaling across the distance between stars. Sleep keeps slipping further away. Your eyes sting from too many hours of watching dots, but the latest data from the Chilean and Indian observatories have you wide awake again. They've begun publishing light curves, long columns of numbers showing how bright each companion appears over time. When you plot them, the curves look wrong in the most interesting way. Instead of the gentle rises and dips of tumbling ice, they pulse, sharp peaks, flat plateaus, sharp peaks again, like something turning square faces toward the sun. You stare at the graphs until they start to resemble a heartbeat. The scientist in you murmurs that geometry can do that. If a flat surface rotates, sunlight flares off it in rhythm. The dreamer in you hears it as a knock on the door of the universe. A mainstream historical fact floats up while you wait for the next data dump. In 1958, the Vanguard 1 satellite became the first human-made object to generate such repeating light curves. Its spin, its shiny aluminum body, all created rhythmic glints visible from Earth. Historians still argue whether that tiny sphere marked the start of the space age or simply the start of our addiction to watching our own reflections in the sky. Either way, you realize with a shiver that Atlas's companions are now producing the same kind of pattern, but out there, light years from any workshop. You sip cold tea and scroll through message boards where amateurs and professionals now mingle like co-workers trapped in the same cosmic mystery. One user posts a compiled animation of 30 hours of data. You click play and watch the companions flash in perfect time, each pulse lining up like a metronome. The caption reads, "If they're random, the universe is better at rhythm than jazz." You laugh aloud, because the alternative, that they're not random, feels too big to hold before breakfast. The official explanations stumble. Specular reflection from fragment facets is the current favourite. Another paper suggests surface sheet oscillation, which sounds reassuringly bland until you read the footnote, requires material with high tensile strength and minimal sublimation. In other words, not rock, not ice, something tougher. A fringe tidbit pops up from a small observatory in Namibia. Their polarization readings show that the reflections are strongly linear, not diffuse, hinting at smooth surfaces rather than dusty ones. The director of the facility mentions it offhand in an interview, only to have the clip clipped, memmed and replayed a million times under the tag mirror rocks. You scroll past endless jokes about space disco balls and interstellar bling, but somewhere beneath the humour is that same uneasy awe. Late in the evening, an update from the Rubin Observatory drops into your feed. The fleet's collective brightness has increased by nearly 12% in a single day. No one can explain why. Maybe they've rotated to catch more sunlight. Maybe something inside them is blooming. The comment section swings wildly between poetry and panic. You post nothing, just watch the pixels. For the first time, NASA holds a press briefing past midnight. A tired spokesperson stands behind the podium, voice steady but eyes wide. "We're observing anomalous reflectivity consistent with changing surface geometry," he says. "We emphasize that natural explanations remain the leading hypothesis." Then someone asks if the light variations could be artificial signaling. He doesn't laugh, doesn't scoff, just clears his throat and says, "That's not our interpretation at this time." You can hear the collective heartbeat of the internet quicken. After the broadcast, you open your curtains and let the moonlight spill across the room. You imagine those companions as pieces of folded metal slowly opening, petals made of mirror. The image feels too cinematic, yet your gut refuses to discard it. You jot down notes, rotation period approximately 3.6 hours, amplitude 0.08 magnitude. Possible geometry, square plate, edge on spin. You pause. If each object really is rotating with such precision, then they're keeping time, perhaps even keeping time with each other. Historians still argue whether synchronized behavior in nature implies coordination or coincidence. Fireflies flash together, birds wheel in murmuration, atoms resonate in quantum lattices, but these objects are not alive, at least not in any sense we understand. You chew your pen cap and wonder if maybe alive just means responding to light and rhythm. Your mind drifts to all the reflective things humans have ever made: mirrors, sails, solar panels, disco balls, and how they always end up symbolizing self-awareness. Maybe that's projection, maybe it's prophecy. Either way, you can't escape the thought that somewhere in those light curves, something might be looking back. At 3 a.m, you refresh the latest feed one last time. A new dataset appears, raw and unfiltered. You plot it quickly and freeze. The peaks are no longer perfectly regular. They've begun to drift in pattern, forming triplets, then gaps, then triplets again. Morse code enthusiasts on social media will soon claim it says hello, but for now you just watch, half convinced, half horrified, as randomness bends toward rhythm. You whisper, "Please be dust," and laugh softly at the plea. The laughter helps. So does the faint sound of the wind outside, the earth reminding you that not all motion hides a message. Before bed, you add one more line to your log. Brightness patterns increasingly structured. Geometry implies design, or very patient coincidence. You underline patient twice. You turn off the monitor and sit in the glow of the cooling screen. The after-image of those pulses dances behind your eyelids, tiny, timed flares echoing across 1 billion kilometers. For a moment you imagine them as beacons marking the road home for someone else. Then, as fatigue finally overtakes you, you remind yourself that they're just like curves on a graph. Still, graphs don't usually make your heart race. Somewhere between sleep and sunrise, you dream of conference rooms. Fluorescent lights buzz, laptops glow, and the air hums with nervous breathing. The world's largest space agencies have gathered behind closed doors to discuss what you already know they can't explain. When you wake, That dream feels too specific, almost like a memory borrowed from someone in the room. By breakfast, leaks have confirmed it. NASA, ESA and JAXA have indeed convened a special review on the ATLAS situation. The official agenda, according to a politely worded statement, is to assess potential risks associated with unidentified interstellar debris. Unidentified. That word alone fuels 1,000 feverish headlines. Every outlet cycles the same images. The bright central body of 3I/ATLAS, flanked by its glittering companions, set against the wide black of space like jewellery arranged on velvet. You can't help imagining the scene inside that midnight meeting. Dozens of scientists around an oval table, exhausted, caffeinated, and trying not to say what they're all thinking. The lead astrophysicist clicks through slide after slide of orbital models, each one refusing to behave. An agency director rubs his temples while a public relations officer practices phrases like non-hostile and non-threatening. Someone probably makes a dry joke, something about hoping the objects come in peace but file tax returns anyway, and the room laughs too loudly because laughter is cheaper than fear. It's a strange comfort, knowing that even the experts are running on caffeine and metaphors. A mainstream historical fact drifts through your mind. In 1967, when the first pulsar was discovered, its rapid radio pulses were so precise that astronomers jokingly labelled it LGM-1, short for Little Green Men. The precision eventually proved natural, a rotating neutron star, but that first impulse to name it after intelligence shows how deeply we crave narrative. Historians still argue whether that moment marked science's humility or its hubris. Tonight, the argument repeats itself with shinier graphics. As the press blackout stretches into the next day, rumours fill the vacuum. Someone posts an anonymous thread claiming to work at Goddard Space Flight Center. According to the post, internal simulations show the companions holding formation within 1% tolerance under solar flux variations. You almost snort tea through your nose. That level of precision isn't physics, it's choreography. But the thread vanishes within hours, deleted for unverified claims. The deletion only fuels belief. Outside, the world keeps functioning, barely. TV anchors lean into their screens with the solemn excitement usually reserved for royal weddings or near misses by asteroids. Commentators debate whether humanity should prepare a greeting message just in case. Someone on Twitter drafts one, "Hello interstellar travellers." Sorry about the internet, it racks up 500,000 likes. You scroll through memes until your pulse slows. Humour again, the universal tranquilizer. But underneath the jokes is a rising undercurrent of real anxiety. If these objects are deliberate, what are they doing near the sun? Why there? A fringe tidbit from an old NASA archive gives you a possible answer. In 1978, the agency tested a concept called solar grazing communications, using the sun's magnetic field as an amplifier for long-distance signal reflection. The experiment failed, but the math suggested that solar plasma could, in theory, serve as a giant resonant dish, an interstellar relay. You lean back in your chair, connecting dots you have no business connecting. What if 3I/ATLAS isn't approaching the sun to die, but to speak through it? Your mind rebels at the thought. It's too cinematic. Still, you jot it in your notebook. Perihelion equals possible broadcast point. Then, to keep yourself grounded, you write beneath it, "No evidence. Stop being dramatic." Around midnight, another leak surfaces, this one more substantial. An email thread between agency officials appears online, dated less than 12 hours ago. You skim through jargon until a phrase stops you cold. We cannot yet determine whether brightness modulation is active signaling or thermal response. The words active signaling burn behind your eyes like after images of a flash. The next morning's headlines explode. NASA email leaks. Is the Atlas fleet communicating? You know how news cycles work. By afternoon, it'll pivot back to denial. But for now, the world trembles on the edge between awe and absurdity. Talk shows host linguists, philosophers, and even a mathematician famous for decoding prime sequences in whale songs. Everyone's an expert tonight. You imagine the real meeting rooms, curtains drawn, phones confiscated, projectors humming. Someone stands, clears their throat and says, "We should prepare for the possibility of public misinterpretation." Someone else murmurs, "It's already too late for that." You can almost see the laughter breaking out again. weary but genuine. Then the tone of reports changes. Journalists begin describing technical interruptions during the press livestream, momentary audio dropouts, video stutters, scrambled timestamps. A few claim that during one blackout an image appeared for half a second showing the fleet closer than predicted, as if the objects had jumped ahead. You doubt it, but when you rewind a screen recording posted online, you do see something. A flash, brief as a blink, that leaves a faint grid of light in your vision. For the rest of the night, you can't decide whether it was compression artifact or an unintended hello. You step outside for air. The sky is cloudless, sharp, indifferent. Somewhere up there, a cluster of unknown bodies moves closer to the sun, maybe tumbling, maybe aligning. You picture the NASA staff now, half exhausted, half exhilarated, realizing that whatever this is, it's history's next paragraph. You whisper, "Good luck, whoever you are," and it's unclear whether you mean the scientists or the objects themselves. Back inside, your screen pings one last time. An astronomer you follow has posted an image tagged #ATLAS_midnight. It's a long exposure capture, the central object gleaming bright, its companions arcing around like points of a crown. Underneath, she's written, "If you stare long enough, every mystery starts to look like an invitation." You copy the line into your logbook, then you dim the screen, letting your room fall into the same darkness the fleet is crossing. Somewhere, in a sealed meeting room, humans are deciding what story to tell the public tomorrow. But tonight, it's just you, a notebook, and the quiet hum of everything we still don't know. By now, you've lost track of the days. The calendar says Thursday, but time feels elastic, stretched thin by sleepless curiosity. Every few hours, new data trickles in through amateur channels, and the graphs you've been making begin to look less like scattered dots and more like deliberate handwriting. The so-called fleet is holding formation, and the world, having burned through panic, now burns through fascination. It begins small. A few citizen scientists coordinate on a forum you've practically moved into. They're from everywhere: Chile, Finland, South Africa, Vietnam, and they decide to pool their images of 3i/ATLAS into a composite map. You join the effort, uploading your own faint exposures, watching as a mosaic forms piece by piece. What emerges on your screen makes your pulse skip, a perfect spiral pattern curling around the main object, delicate as a seashell. It's not proof of design. Humans are good at seeing patterns where none exist, but the symmetry is eerie. One participant jokes, "We've crowdsourced a crop circle in space." Another replies, "Yeah, and it's the prettiest spreadsheet I've ever seen." Within hours, a shared spreadsheet appears, color-coded by observer location. The group nicknames themselves the ATLAS Cooperative, equal parts science project and support group for the cosmically sleep-deprived. You take the midnight shift, collating, verifying, adjusting for atmospheric distortion. It's strangely peaceful, this silent teamwork that spans continents. A mainstream historical fact hums in your memory. In 1889, the Eiffel Tower was used as one of the first global time signal transmitters, uniting observatories across nations. Before that, astronomers relied on telegraphs and goodwill. Historians still argue whether that synchronization of clocks was the moment the world began to think like one brain. Tonight, as your group of strangers aligns their lenses to the same patch of sky, you think, maybe this is what that felt like. The group chat scrolls by like a living organism, graphs, jokes, blurry cat pictures. Someone posts a calculation suggesting that if the fleet were artificial, the energy required to maintain formation would be minuscule if they were using solar sails. Another responds, "So we're basically watching the galaxy's slowest parade." Then something astonishing happens. A new member from Argentina uploads a fresh exposure. When the images are stacked and averaged, the brightness ratios of the companions produce a faint interference pattern, almost like a barcode. You blink, zoom in, and see a repeating rhythm. Bright, bright, dim, bright, bright, dim. Someone converts it into binary out of sheer boredom and gets the sequence 101. It's meaningless. Probably just a fluke of pixel stacking, but it sends a thrill through the chat. You type, "Let's not go full alien on this yet," but your fingers tremble anyway. Outside your window, dawn bruises the sky. You make another pot of coffee, pretending it's for data integrity, not superstition. On your phone, global news outlets have finally picked up the cooperative's mosaic. The headline reads, Citizen scientists map InterstellarObjects companions in stunning detail. You grin. For the first time in weeks, the narrative isn't fear or secrecy, it's collaboration. Still, the professionals can't ignore what the amateurs have uncovered. The European Space Agency releases a short statement acknowledging the cooperative's contribution and quietly confirming the spiral pattern's authenticity. The tone is careful, but the admission feels like electricity. You scroll through the comments and see a single line repeated like a mantra. We're all looking together. It's funny how quickly collective mystery becomes collective comfort. When Galileo aimed his telescope, he was excommunicated. When you aim yours, you get upvotes. Maybe progress just means finding better ways to argue with curiosity. Midway through the night, the chat pings with something new. A file from an Australian observatory, raw, unfiltered imagery. You load it and stare. One of the companions has split cleanly in two, its fragments moving apart by only a few kilometres, but maintaining perfect alignment with the rest. Could be sublimation fracture, someone suggests. Another replies, could be replication. Laughter emojis follow, but no one sounds entirely convinced it's a joke. You refresh the live data. The fragments shimmer, catching sunlight like twin mirrors. The spiral tightens slightly, almost imperceptibly. You imagine clockwork mechanisms hidden beneath those distant surfaces, adjusting, realigning, breathing. To stay grounded, you look up an old quirky tidbit. During the 1969 Apollo missions, astronauts reported that the moon rang like a bell when struck by discarded modules. Evidence some claimed that it was hollow. The idea was nonsense, of course, but the phrase stuck. The moon rang. You think about that now, about how every generation finds its own echo in space and decides to call it music. The cooperative begins streaming their findings live. A soft-spoken teacher from Japan narrates as new data arrives. Her voice is calm, almost ASMR-level soothing. Here, she says, highlighting the pattern of the companions. They behave as if following a hidden equation. Beautiful, isn't it? The chat explodes with hearts in sleepy awe. Then something subtle happens midstream. For a few seconds, all the brightness levels dip simultaneously, each object in the formation blinking out, then returning. It's brief enough that you might miss it if you blink, but the timestamps show perfect synchronization, down to the millisecond. The teacher pauses. Could be telemetry dropout, she murmurs, though her tone suggests she doesn't believe it. You stare at your own monitor, replaying the dip in a loop. Every instinct screams that data glitches don't coordinate across continents. The word fleet feels heavier now, less metaphor, more geometry. Outside, clouds are gathering, but the air buzzes like static. You close your eyes and imagine those faint points of light blinking in unison, like eyes adjusting to sunlight. The idea should scare you. Instead, it soothes you. Maybe because the longer this mystery lasts, the more humanity feels like a single mind leaning toward the same window. You jot in your notebook, citizen networks confirm symmetry, global cooperation, possible synchronous dimming event. If message, then language equals light. Then, half laughing, you add, also need sleep. But you don't sleep. Not yet. Because the moment you close the lid of your laptop, another ping arrives, an alert from a new amateur telescope array in South Africa. The caption reads, "Pattern shift detected. They're turning." You open the new images before your coffee has even finished brewing. The South African array's data loads in a mosaic of red, green, and false ultraviolet, each pixel a whisper from millions of kilometers away. And there it is, undeniable. The entire configuration of companions around 3I/ATLAS has rotated 90 degrees relative to their previous plane. Not scattered, not tumbled, rotated. Your heart does the strange thing it's been doing lately, skipping awe and going straight to stillness. Because sometimes, when the sky gets weird enough, your mind stops resisting and just listens. You replay the composite. The main body of Atlas holds its slow curve toward the sun, while its entourage pivots like dancers changing formation mid-routine. You feel a chill that has nothing to do with the morning air. Within hours, the cooperative's group chat is chaos. Half celebration, half disbelief. People are comparing timestamps, instrument angles, anything to prove or disprove what everyone's seeing. One member jokes, maybe they're just adjusting for better selfies. Another replies, then they're photogenic and polite. But even through the humour, you can sense the awe. Professional astronomers move fast. By noon, NASA and ESA both confirm the rotation, though the wording is predictably sterile. The cluster exhibits non-gravitational attitude variation. Translation: something just turned that shouldn't be able to. You reread the statement until it feels unreal. You imagine the control rooms, the hushed teams rechecking math, muttering non-gravitational, like it's a spell that keeps the impossible at bay. A mainstream historical fact drifts up. In 1929, Edwin Hubble proved the universe was expanding. Before that, scientists thought galaxies were static islands. The discovery shattered cosmology overnight. Historians still argue whether the shock of that revelation, space itself stretching, was ever fully absorbed. Maybe it wasn't. Maybe every few decades the universe reminds humanity that settled science is just a polite pause. You decide to step outside because screens can only translate so much. The early evening sky burns orange, the sun low and swollen. Somewhere near that blinding glare, invisible to your eyes but not to your instruments, the fleet is aligning again. You wonder if they're adjusting to face the sun directly or perhaps to face us. A breeze brushes your cheek, cool and deliberate. You think of sails catching wind, and then, inevitably, of intention. Back online, speculation has gone supernova. Some astrophysicists propose that the rotation could result from uneven heating, the YORP effect, named for a set of scientists who studied how sunlight can spin small bodies over time. The explanation sounds comfortingly familiar. Then a counterpaper points out that such talks would take months to cause this degree of change. The fleet did it in under a day. You can almost hear the collective shrug of the cosmos. Then come the myths. An Egyptian historian posts side-by-side images of the formation and a carving from Dendera Temple, a spiral of stars surrounding the sun god Ra. The resemblance is loose but eerie. Within hours, ancient astronaut forums explode with theories about sky fleets and solar deities returning. You scroll through the posts, half amused, half entranced. Humanity always wants the stars to talk about itself. A quirky tidbit pops up in the cooperative chat. A linguist notes that the new arrangement of the companions forms an approximate pattern matching ancient petroglyphs found in the Atacama Desert. 7 points in a curved line, a symbol some interpret as those who watch the dawn. The resemblance is coincidental, surely, but it spreads like wildfire. The line between science and myth blurs beautifully for a night. Still, you remind yourself that patterns can lie. They seduce the eye into meaning. You jot in your notebook, rotation confirmed. Correlation does not equal intention. You underline it twice, then add, but still, weird. Later that night, a new livestream begins from a mountaintop observatory in Chile. The astronomer hosting it, your favourite soft-spoken one, the woman who always sounds like she's narrating a bedtime story, stands under a sky alive with stars. Behind her, on a giant projection, the fleet glows faintly beside the sun, its formation unmistakably shifted. Tonight, she says, we're witnessing an alignment that defies our models. Whether it's natural or not, it's magnificent. Her voice trembles slightly on that last word. You imagine the whole planet watching her stream, the collective quiet, the held breath. For once, the comment section behaves. People type their city names, their time zones, their weather, as though mapping humanity in return. The feed becomes a chorus of presence. Suddenly, mid-broadcast, the image stutters. The companions brighten for 3 seconds, then dim in a slow gradient. The chat explodes. The astronomer blinks at the screen and says softly, "It's like they're reflecting something." Then the feed cuts. When it returns, she's smiling awkwardly, saying it was just an exposure glitch. You want to believe her, but when you scrub the playback, the synchronized glow is still there. Faint, deliberate, impossible. You close your laptop and sit in the dark for a while, letting your breathing slow. You think of all the light that travels across space without meaning, and how a single flicker can make humans invent gods. You wonder if maybe that's the point. Maybe wonder itself is the communication. Outside, the night deepens. A neighbour's dog barks once, uncertainly, as if sensing something beyond hearing. You lean against the window pane, whisper, "If this is a message, we're listening." In your notebook you write, "Fleet turned toward the sun or Earth, unclear. Possible synchronization event. Global reaction, reverent, not afraid." You pause, tapping the pen, then add a softer line. Feels like the sky took a breath. You exhale with it, your reflection faint in the glass superimposed on the stars. You're sitting in a dark room again, the hum of your equipment as steady as your heartbeat. For the past 2 nights, data streams from every observatory have become almost musical. Fluctuations rising and falling in patterns too structured to be random, too subtle to be confident. No one's calling it a message, not officially. But everyone's whispering that word as if it's fragile glass. You've plotted the new coordinates yourself, frame by frame. The companions no longer travel in a fixed spiral. Their paths weave inward, crossing and separating, forming what looks like calligraphy written across space. You play the time-lapse and can't help but think it looks intentional, each orbit a brushstroke, the total image forming only when you zoom out far enough to lose your breath. By dawn, data analysts online have already run Fourier transforms, searching for mathematical repetition. They find it. The relative angles between the companions follow ratios, 3 to 2 to 5, familiar constants of resonance. Someone points out that those ratios match the orbital harmonies of Jupiter's moons, Io, Europa, and Ganymede, where gravitational tug keeps them in rhythm. Coincidence, maybe, but your pulse doesn't believe it. A mainstream historical fact drifts through your tired brain. In 1974, the Arecibo telescope transmitted humanity's first deliberate interstellar message, a stream of binary coded into radio waves aimed at a globular cluster 25,000 light-years away. It contained numbers, atomic elements, and a stick-figure human. Historians still argue whether the Arecibo message was an act of optimism or hubris, a shout into an indifferent universe. Now, half a century later, the universe might be whispering back, not in binary, but in orbits. As daylight spills through the window, you refresh the live feed. The fleet continues to move with impossible grace. Several of the companions trace looping arcs that seem to converge into geometric intersections, lines crossing, forming nodes, then pulling apart again. You map those crossings onto a 2D projection, and the pattern that emerges chills you. It's a grid. Not perfect, but structured enough to look deliberate, almost like a schematic. You try to dismiss it. Maybe it's just geometry emerging from orbital coincidence. After all, nature loves patterns. Honeycombs, snowflakes, planetary rings. Still, you hear the voice of the Japanese astronomer from last night's stream, soft and awestruck. They behave as if following a hidden equation. A quirky tidbit surfaces from an online archive. Mathematicians studying chaos theory once demonstrated that even random systems can produce apparent order if observed at the right interval. You can trick yourself into seeing purpose, one wrote, because the human mind can't stand coincidence. You cling to that sentence for comfort, though it's starting to feel like denial in a lab coat. By afternoon, the cooperative is aflame with excitement. Someone's algorithm detects periodic dimming across the fleet, timed at intervals that correspond to the Fibonacci sequence. You blink at the numbers, it can't be right. But when you check the raw data yourself, the timing holds. You stare at your monitor, the spiral of ratios echoing the very pattern of life itself. Shells, seeds, galaxies, and now, possibly this. You mutter, "All right, universe, that's a bit on the nose." Meanwhile, the agencies stay quiet. Too quiet. A leaked transcript surfaces from an internal NASA call. Fragmentary, filled with static, but you catch one phrase clearly. If it's deliberate, it's not aimed at us. It's aimed at the sun. You sit back stunned. What does that even mean? Then it hits you. The pattern, the geometry, the alignment, it all converges not toward Earth but toward the solar surface. The companions' synchronized rotations, the tightening spiral, all of it seems to focus energy inward, as if tracing invisible pathways through the sun's magnetic field. Maybe they're using it as a lens. Maybe this is what the message looks like before it speaks. You step outside, barefoot on cool grass, the air sharp with the promise of dawn. You can't see 3I/ATLAS. It's too close to the sun now, lost in glare, but you feel its presence, heavy and bright. Somewhere up there, objects from another star are either falling apart or assembling into coherence, and you, a small creature on a small planet, are watching from the shadows. You laugh quietly to yourself, the sound equal parts disbelief and surrender. You probably won't survive this, you murmur, echoing the cheeky tone of your own introductions. The sky doesn't answer, but you think it enjoys the callback. Hours pass. The online community has stopped arguing and started listening. Streams loop in silence while data scrolls like sheet music, numbers as notes, resonance as rhythm. The pattern becomes too intricate to decode in real time. Someone overlays the companion paths across solar magnetic field lines, and the match is uncanny. It's as if the fleet is threading the sun's unseen tapestry, weaving lines through plasma loops that stretch millions of kilometers. Historians still argue whether art and science are opposites or twins. Watching those luminous bodies choreograph themselves across the star, you decide it doesn't matter. This is both a proof and a poem written in fusion fire. That night, you dream again. You're floating above the sun, surrounded by the companions. They hum, not with sound, but with motion. Their orbits pulse in harmony, and as they move, you feel something vast and gentle brushing your thoughts, like fingers tracing curiosity itself. When you wake, the dream clings to you like static, a whisper fading into morning. Patterns are invitations. You write the phrase down before it vanishes. Beneath it, you add your final note of the night. If this is a message, it's being written in light and motion. We just need to learn how to read. Outside, the world spins quietly, oblivious to how close its star is to becoming a conversation. The sun is waiting. That's how the new headlines phrase it anyway. Half awe, half melodrama. You don't mind. For once, the dramatics feel deserved. Every hour now, 3I/A TLAS, and its silent entourage drift closer to perihelion, the moment of nearest approach, when they'll either blaze apart or reveal whatever choreography they've been saving. You've stopped pretending you can do anything else. Work emails go unanswered, dishes pile up, time itself bends around data releases and live streams. The world feels like it's holding its breath alongside you. The latest solar instruments have turned toward the phenomenon SOHOSTERE, Parker Solar Probe, all catching glimpses between pulses of radiation. The images are unstable, washed in noise, but even through distortion you can tell something new is happening. The companions have begun to compress, drawing inward toward the main body of ATLAS in a perfect spiral. The motion looks almost gravitational, but too clean, too symmetrical. You record it frame by frame, trying to convince yourself this is just the sun's pull. A mainstream historical fact bubbles up. In 1680, the Great Comet passed so near the sun that its tail stretched halfway across the sky. People thought it was an omen, a celestial sword. Historians still argue whether those early observers saw divine wrath or scientific wonder. You think about them now, staring up at streaks of fire, trying to find meaning, and realize you're doing the exact same thing, just with better Wi-Fi. Solar physicists flood social media with updates. We expect fragmentation, one writes. At these temperatures, volatiles sublimate instantly. Yet the fleet does not scatter. Instead, the entire formation grows brighter. You rub your eyes. Brightness should mean disintegration, but the edges remain sharp, their orbits disciplined. It's as if the heat is energizing them, a commentator says during a live stream, her voice trembling. You open the real-time feed from the Parker probe. Data flickers across your screen. Spectral spikes, radiation bursts, faint anomalies in the solar wind density. Then, amid the static, one sequence stands out, repeating magnetic oscillations perfectly periodic. It's not unheard of. Solar flares can create rhythmic waves, but these pulses match the companion's orbital timings exactly. You whisper, "Oh, come on," into the empty room. A quirky tidbit drifts from your overloaded brain. During Apollo 12, one astronaut described lightning-like discharges flickering along the lunar horizon, likely solar particles hitting the equipment. "It was like the moon was talking in sparks," he said later. You glance back at the Parker data and think, the sun is talking in harmonics. The chatter across observatories rises to fever pitch. Live stream hosts alternate between excitement and dread. The cooperative channels look like digital bonfires, thousands of watchers refreshing the same feed. You join one called Solar Gatewatch, a 24-hour loop of the SOHO imagery with lofty music and scrolling comments. It feels oddly peaceful, thousands of people silently waiting for the same revelation. Then, near dawn, the moment arrives. The Zoho feed catches a burst of light, a flare that should be the death of Atlas. But instead of vaporizing, The central object remains intact, blazing white-hot, its companions forming a halo around it. For 3 seconds, the brightness overwhelms the sensors, a false sun blooming within the real one. When the glare clears, a gasp ripples through every chat room on Earth. The fleet is gone, not dispersed, not destroyed, just vanished. You freeze. Then the secondary cameras come online, showing something extraordinary. Faint shadows moving behind the coronal plasma, like shapes slipping through a curtain of fire. You can't see edges, only suggestion, a geometry where no object should survive. The internet combusts with interpretation. Some claim the fleet disintegrated into vapor, others insist it entered the sun. A few, less comfortably, suggest it passed through. NASA and ESA stay silent for nearly 12 hours, which tells you everything. When a statement finally comes, it's brief. All tracked bodies have ceased reflecting light. Their trajectories are indeterminate. You can practically hear the exhausted sighs behind those words. You step outside. The daylight feels heavier now, like the air itself is listening. The sun hangs indifferent and magnificent in a pale sky. Somewhere inside that brilliance, maybe, something just changed forever. You remember an old fringe idea from the 1970s, Freeman Dyson's speculation that advanced civilizations might live around stars, building vast shells to harvest their energy. If they exist, he said, we'd see their signature in the light. You look up and think, or maybe we wouldn't see it at all. Historians still argue whether human awe ever leads to humility. You suspect it might, but only after the wonder fades. Right now, humility feels premature. By evening, new data begins to leak. The Parker probe's instruments recorded one last pulse before the signal dropped. A burst of radio and magnetic noise lasting exactly 7 seconds. Analysts overlay it with earlier fleet oscillations and the match is perfect. 7 seconds, 7 companions in the inner ring before the merge. Some call it coincidence, you don't. Theories multiply. Solar gateways, magnetic tunneling, higher dimensional transitions. You try not to choose any of them. Instead, you write your notes. Brightness spike. Objects intact, post-flare. Disappearance equals unknown. Final signature, 7-second pulse. You stare at the words until they blur. Outside your window, sunset spills across rooftops, the same orange that once painted cave walls and inspired the first stories about gods. Maybe this is just another story in that lineage. Maybe the fleet was natural, an illusion of light and gravity. But maybe you think it was something showing us how to look at the sun differently, less as fire, more as a gate. As darkness folds over your city, you whisper to the horizon, if you made it through, send a postcard. The sky answers with nothing but starlight, and yet somehow that feels like a yes. You wake to an empty sky. For the first time in months, there are no new coordinates, no updated brightness curves, no fresh images to stitch together. The world has entered a collective pause, an awkward hush after the applause. The fleet, or whatever it was, has vanished behind the sun, and nothing, no instrument, no orbiting satellite, has yet seen it re-emerge. You pour coffee and stare at the pale morning light creeping across your window. There's something almost insulting about how normal everything looks. The planet didn't crack in half, communications didn't fail, the sun didn't explode in a revelation of meaning, and yet the air feels heavier, like a curtain waiting to be pulled back again. You open your favourite feed, Solar Gatewatch, still looping the final frames before the flare. The chat is quieter now, less shouting, more whispering. Someone's pinned a timestamp, 03/1947 UTC, the moment the light spiked and every sensor on Earth blinked blind. The playback stops on that frame, the fleet frozen mid-formation, the white-hot bloom about to swallow them. Then the clip jumps forward 3 seconds and there it is, the flare that wasn't. You watch it again, full screen, volume low. The solar corona swells outward, a halo of pure brilliance. The instruments should have been blinded, but the exposure registers a strange anomaly. A secondary flash within the flare, smaller, sharper, impossibly bright. Brighter than the sun itself for a heartbeat. That's what they're calling it online now, the heartbeat. You rewind, frame by frame. The anomaly appears as a single pixel of pure white, pulsing once before the flare peaks. Every observatory captured it. No one can agree what it means. Some say it's a camera artifact, others call it the final signature of the fleet's disintegration. You find neither explanation satisfying. A mainstream historical fact drifts into your thoughts. In 1859, during the Carrington event, a massive solar flare hit Earth, frying telegraph systems and painting auroras over the tropics. But even that world-changing burst didn't outshine the sun. Nothing does. Until, maybe, now. Historians still argue whether Carrington actually witnessed the first hint of space weather science, or just the raw temper of a living star. Either way, his name became shorthand for too close to the fire. You think about that single, impossible pixel, the way it pulsed like a signal before the flare swallowed it, and wonder if humanity just watched someone else get too close to the fire too. Official channels flood the internet with measured calm. NASA calls the flash a localized overexposure event. ESA adds that data irregularities are common in extreme solar imaging. But tucked between the lines, there's a quieter admission. Every magnetometer on Earth recorded a pulse at that same second. Even instruments facing away from the sun. You reread that sentence 3 times. Magnetic fields everywhere, from Antarctica to the ISS, spiked and dipped in perfect synchrony. A worldwide heartbeat. You join a live stream hosted by a soft-spoken astrophysicist in Tokyo, the same one who guided you through the first sighting months ago. Her voice is steadier now, but her eyes look tired. "We don't yet know what we saw," she says, "but we know the sun did not produce that pattern alone. Something interacted with it." She glances down at her notes. If you measure the interval between the pulse and the magnetic echo, it matches the spacing of the companions before the merge. She hesitates, then adds, "Perfectly." The chat explodes. You sit very still. A quirky tidbit floats through your tired brain. Physicists once joked that the universe might be a vast electromagnetic resonance chamber, every atom vibrating in sympathy with some hidden cosmic frequency. Maybe the fleet just plucked one of those strings. Maybe we're still humming. Historians still argue whether collective silence counts as understanding. You think it might. For the first time since the beginning, no one online is pretending to have the answer. The memes stop. The arguments cool. All across the world, people simply watch the same blank quadrant of space and wait for something to return. You step outside, blinking against the bright day. There's a strange clarity in the sunlight. Crisp, almost metallic. Maybe it's psychological, maybe not. You can't help imagining that the sun has changed slightly, that its face now carries the faintest memory of what passed through it. On a whim, you set your old portable radio to scan frequencies. It hums, crackles, whispers, nothing unusual. And yet, when you pause it at random, there's a faint rhythmic hiss. 3 short bursts, one long repeating every few seconds. You frown, record it, play it back. The pattern persists. Could be static, could be imagination, but it syncs eerily with the magnetic data timestamp. You smile, half in fear, half in wonder. You write in your notebook, heartbeat detected. Duration, 1.4 seconds. Global magnetic echo confirmed. Post-event signal, possible aftershock, then smaller. If they burned beautifully. Night falls. You join the cooperative's video call. Faces lit by screens, voices soft and uncertain. The teacher from Japan, the intern from Chile, the retired engineer from France. You've all been through this together, and now there's nothing left to observe. Just waiting. Someone plays back the heartbeat sound, converted from solar data into audio. It's low and deep, like a single drumbeat slowed to eternity. You feel it in your chest more than you hear it. The group falls silent. No one jokes this time. Finally, someone whispers, maybe that was them saying goodbye. You don't answer, because what can you possibly add to that? Instead, you lean back in your chair, close your eyes, and listen to the lingering echo of that pulse. It's fading, yes, but part of you thinks it might never fully stop. Outside, the night sky glows faintly with auroras that shouldn't be there, green curtains flickering even at the equator. The news calls them magnetic anomalies. You call them handwriting. For now, the fleet is gone, the instruments quiet. But as the auroras ripple above your city, you realize that silence too can be a kind of reply. For 2 days, the world feels like it's floating between exhale and inhale. No new images, no statements, just that odd planetary hush after the heartbeat. People return to work, sort of. Teachers pause their lessons mid-sentence to glance at classroom windows. Air traffic controllers confess they've been listening for radio hiss between flights. Even the markets flicker slower, as if algorithms themselves have taken to stargazing. And then, just when calm begins to taste real again, the echoes arrive. It starts with an array in Alaska reporting instrumental interference, a polite phrase for something weird just hummed through our antennas. The pattern is faint but deliberate. 3 pulses, 2 gaps, 3 again. You check the timestamp, exactly 48 hours after the heartbeat. Within minutes, observatories from Chile to Kazakhstan confirm they've caught the same rhythm, though on slightly different frequencies. The signals don't match any known satellite transmissions. You open the live magnetometer dashboard. Spikes blossom like goosebumps across the map of Earth. Each one tiny, each one timed. Whatever the fleet did at the sun, its signature is still rippling outward, an invisible tide brushing every compass needle on the planet. A mainstream historical fact steadies you. In 1972, when the Apollo 16 crew returned from the moon, they brought instruments that later detected subtle magnetic oscillations echoing from solar storms, proof that space weather could literally ring the Earth. Historians still argue whether those early detections were science's first whisper of space climate. Tonight's data feels like a storm of meaning instead. The agencies are cautious. NASA releases a 12-word statement. Localized electromagnetic anomalies consistent with post-solar flare harmonics under review. Translation: we have no clue. ESA holds a brief press conference. The spokesperson's smile looks surgically installed. Natural resonance, she repeats, as though repetition alone will make it so. You know better. Natural resonance doesn't keep perfect time across hemispheres. By nightfall, the cooperative is buzzing again. Someone overlays the magnetic spikes onto a world map and realizes they form sweeping arcs, great circle paths converging near the poles. Looks like lines of longitude learning to dance, one user writes. Another jokes, maybe the fleet gave Earth a tuning fork. You grin, grateful for humor's persistence, even here. Then a small observatory in Argentina uploads something extraordinary. A recording of low-frequency radio waves, converted into audible sound. You put on headphones. The noise starts as a hiss, then resolves into rhythmic pops, soft, measured, insistent. Beneath them runs a deeper tone, a rolling thrum like wind inside a cavern. You close your eyes. It sounds almost alive. A fringe tidbit flickers in your memory. In 2006, scientists mapping Earth's magnetosphere discovered chorus waves, natural radio emissions that literally sing through plasma, audible when converted to sound. They called it the dawn chorus. What you're hearing now is slower, steadier, less playful. A dusk chorus, maybe, a farewell in frequencies. Historians still argue whether music counts as a universal language. You suspect it does, but only for those patient enough to listen past the static. Around midnight, the Parker Solar Probe regains partial telemetry. Its instruments, briefly fried during the flare, are now streaming again. The data reveal something breathtaking. Magnetic ripples moving outward from the sun in perfect concentric waves, expanding faster than solar wind should carry them. Each wave corresponds exactly to the Earth's recorded pulses. Whatever happened inside that blaze wasn't destruction. It was a mission. You whisper, they're still talking. The next day, a quiet miracle happens. Auroras return, faint ribbons even under daylight, visible through polarized lenses. The world notices. Social media fills with videos, people standing on beaches, rooftops, mountaintops, filming the sky glowing emerald and violet at noon. Children laugh, elderly strangers hug. The internet christens it the Echo Light. Every scientist you follow insists the phenomenon is magnetic residue from the flare. Every poet online insists it's a reply. For once, you think both might be right. You go outside at dusk. The horizon glows faintly turquoise, the colour of bottled silence. A neighbour waves and says, "You think it's safe?" You shrug. Safe enough to be beautiful. The air feels charged, almost tactile, as if the atmosphere has grown thin between worlds. Somewhere overhead, invisible lines of force hum with leftover information. You picture the fleet beyond the sun, still intact, maybe coasting outward on some trajectory no one has yet predicted. Maybe what you're feeling is their wake, a cosmic aftershock crossing interplanetary space. You find yourself murmuring the words you wrote weeks ago, patterns or invitations. Then you add softly, and echoes are answers. Back indoors, you check your radio again. The same rhythm persists. 3 pulses, 2 gaps, 3 again. This time, between bursts, you think you hear something new. Faint modulations, like tremors of a voice stretched thin by distance. Could be interference from a power line, could be history rhyming with itself. You open your notebook and write, echo events recorded globally. Possible structured repetition, light anomalies continuing. The sun remembers. Then beneath that, smaller. If they meant to erase themselves, they failed. We can still hear the footprint. At 3 a.m, you drift towards sleep to the slow pulse of that signal playing through the radio's static. The world's heartbeat grown faint but steady. Outside, the aurora curls once more across low clouds, tracing an unseen geometry you almost recognize. The sun's invisible music washes over you, and for the first time in months, the fear is gone. You're left only with wonder and the quiet certainty that whatever left those echoes did not end in the fire. It began there. 3 nights later, sleep feels optional. The air carries a faint metallic taste, the kind you notice before a thunderstorm or after a miracle. The auroras have dimmed but not vanished. Instead, they shimmer low on the horizon like memory refusing to fade. You sit at your desk, the radio still murmuring its low, patient rhythm, when a new alert flashes across your feed. Multiple new objects detected leaving solar vicinity. For a long moment you don't move. You read the sentence again, then again. The words refuse to simplify. Every major observatory has confirmed it. Telescopes in Hawaii, Chile, and the Canary Islands have picked up faint streaks moving away from the sun, small, steady, luminous bodies accelerating outward at unusual velocities. The trajectories don't match any known comets, and they certainly don't match what went in. Someone runs the math and posts it to the cooperative. At least 25 distinct objects, possibly more, emerging from the inner system in divergent paths. Your stomach flips. 25. There were 7 companions in the inner ring before the flare. The numbers don't line up. It's as if the sun gave birth to new travellers. A mainstream historical fact steadies your spinning thoughts. In 1994, fragments of Comet Shoemaker-Levy 9 slammed into Jupiter after being torn apart by its gravity, a spectacular destruction that produced 21 visible impacts. Historians still argue whether that event marked the beginning of our understanding of planetary defense or our obsession with cosmic disaster. What's happening now feels like the inverse of that story, not a breaking, but a multiplication. NASA's official statement calls them post-solar fragments. They describe the velocities as unexpectedly consistent, the spacing as unusually regular, and the reflectivity as currently under investigation. Each phrase is a folded note hiding panic between the lines. You step outside, unable to sit still. The air is clear and cold, the stars crisp enough to cut yourself on. Somewhere out there, beyond the glare of daylight, the sun has just released something into the dark. You can't see them, of course, but knowing they're there feels like hearing footsteps in another room. The cooperative chat erupts with theories. Some say the fleet survived the flare, shedding damaged layers as they fled. Others argue that they transformed, that the intense radiation split their surfaces like seeds under heat. Replication, someone types, half-joking. Solar mitosis. You stare at the phrase longer than you should. A quirky tidbit surfaces in the chaos. A university lab in Norway, reviewing Parker probe data, notices a peculiar chemical signature in the flare's aftermath. Trace elements consistent with vaporized titanium and something else, something unclassified. Not in any known meteor spectrum, the report notes. The line disappears quickly from the public summary, but screenshots survive. Titanium, the metal used in spacecraft hulls. Historians still argue whether conspiracy thrives on ignorance or curiosity. Tonight, both are having the time of their lives. Meanwhile, the new objects continue to brighten. Spectroscopic readings reveal mirrored surfaces smooth and reflective. Their light curves pulse faintly, rhythmic, familiar. You feel that old chill again, the same pulse you saw weeks ago, echoing now in a new generation of travellers. The world's media regains its frenzy. Talk shows ask whether we've witnessed the birth of solar probes. One anchor actually says it aloud. If this was intelligent activity, perhaps it wasn't aimed at Earth, it was aimed through Earth. The phrase ricochets across the internet like prophecy. You scroll through your feeds until you find the live tracking map, 25 points drifting outward in perfect radial symmetry, like dandelion seeds blown from the sun, each one steady, unwavering, accelerating as if remembering where to go. The cooperative revives the Lofi stream, data scrolling like lullaby lyrics. Someone overlays the new paths with the orbital planes of nearby stars. You freeze when you see it. Several trajectories align almost exactly with known interstellar destinations. Epsilon Eridani, Proxima Centauri, Tau Ceti. Coincidence maybe, or maybe homing instinct. You whisper, they're leaving roots. The same Japanese astronomer who comforted you through the rotation event posts a short video. She sits in near darkness, the aurora's glow faintly visible through her window. If they were explorers, she says softly, the sun was their harbour, and now they are setting sail. Her voice cracks on sail. You realise you're crying, though you're not sure why. You turn your radio back on, tuning it slowly. The static's still there, the same 3 pulses and 2 gaps, but tonight it sounds weaker, thinner, like someone walking away while speaking. You hold your breath, counting the rhythm until the noise fades entirely. The silence afterward feels alive. Outside, the aurora flares one last time, a sweep of emerald fire stretching across the sky. You think about all the watchers across the planet, each of them standing on their own balconies, beaches, rooftops, eyes tilted upward, united by the strangest bedtime story humanity has ever shared. You jot your notes, post-solar objects emerging, 25 confirmed, reflective surfaces, outward acceleration, possible replication event, chemical anomaly, titanium. Magnetic aftershock subsiding, silence equals transition. Then, underlined twice, maybe we just witnessed the sun teaching something to leave. You sit quietly after writing that, unsure if you mean the fleet or yourselves. The stars above seem brighter than usual. Perhaps they always do after loss. The next morning, observatories confirm the outbound objects are leaving the solar system entirely, their trajectories stable, their speeds increasing beyond solar escape velocity. They're gone, not vanishing this time but travelling, carrying the memory of sunlight with them. You close your notebook and whisper, "Safe travels." And for the first time since this began, you don't open your telescope. You just let the morning light hit your face, knowing that somewhere beyond that brightness, 25 sparks are tracing invisible lines toward other suns. Days pass, then a week, and the world slowly relearns the quiet art of not knowing. The feeds that once roared with hourly updates are now muted, their timelines stretching between speculation and silence. You find it strangely peaceful, like the intermission of a play too beautiful to end. Yet, underneath that calm, something feels missing. The new outbound objects continue their escape, faint streaks drifting past Mercury's orbit, then Mars's. Observatories track them obsessively, but every measurement comes with a new frustration. Missing data, corrupted frames, timestamps that don't align. It's as though every instrument on Earth and in orbit has developed selective amnesia. You're scrolling through the Cooperative's channel one evening when the first real whisper breaks. Anyone else getting blank frames in their capture logs? At first, it's just a few users, then dozens, then everyone. Images vanish mid-transmission, metadata reorders itself, even local backups come up empty. It's as if the information never existed in the first place. NASA releases a bland bulletin blaming solar interference. You snort softly into your mug. Solar interference doesn't delete entire datasets. You've seen this before. Digital silence, precise and merciless. Years ago, when you worked in research, a classified satellite's telemetry vanished the same way, scrubbed clean by an automated overwrite script. Officially, it was compression failure. Unofficially, it was censorship. You feel the same chill crawling up your spine now. A mainstream historical fact floats to mind. In 1969, the Apollo 11 mission recorded hours of telemetry and video that were later lost. NASA claimed they'd reused the magnetic tapes for budget reasons. Historians still argue whether that explanation was honest incompetence or a tidy lie. Either way, humanity's most famous conversation with the moon went partially missing. Now, it feels like the universe has learned the trick. You sit back from the screen, rubbing your temples. They're erasing the evidence, you whisper, unsure whether you mean the agencies or something else. Then a new kind of message appears, private, encrypted, forwarded through 3 proxies before reaching you. The sender calls themselves Mirror Song. No real name, just a signature, a stylized spiral. The attachment is a single still image. You open it. It's a high-contrast frame from the SOHO satellite, supposedly taken seconds after the fleet's disappearance weeks ago. At first glance, it looks like a smear of solar plasma, but when you adjust the levels, faint shapes emerge, lines and arcs etched across the light like script on burning parchment. Not random, not natural. They look like, no, they are letters. You recognize fragments of Earth's languages tangled together, bits of Cyrillic, Arabic, Greek. Others are unfamiliar, angular, elegant. It's impossible, and yet you can't look away. The caption under the image simply reads, "The flare spoke." You blink, stunned. Maybe it's a hoax, an artist playing with data noise, but something about it feels different, too symmetrical, too layered. You save the image anyway, half expecting it to vanish like the others. It doesn't, at least not yet. That night, the cooperative erupts with talk of ghost data. People report strange flickers in their stored imagery, frames that seem to rewrite themselves when reopened, faint symbols flickering through the noise. You try not to romanticize it, but the term digital haunting feels apt. A quirky tidbit surfaces from an academic blog before it's deleted. A linguistics team in Turkey claims the patterns resemble proto-writing, markings older than human civilization, predating formal alphabets. The team's server goes offline within hours. Historians still argue whether censorship protects truth or kills curiosity. You suspect both can be true, depending on who's doing the protecting. In the absence of new data, the world turns to philosophy. Podcasts, essays, late-night debates, all circling the same question. If something truly alien touched our sun, what should humanity do with that knowledge? Some say disclose everything. Others argue that mystery is mercy, that knowing too much too soon breaks the species. You listen quietly, feeling both smaller and larger than you've ever felt. Around midnight, your radio hums again. The signal, the 3 pulses, 2 gaps, has returned, softer but cleaner, stripped of interference. You press record and lean close. There's something under the rhythm now, a modulation like breathing through static. You run a spectrogram on it, and your chest tightens. Hidden in the waveform's noise are repeating intervals, sequences matching those faint symbols from the Mirror Song image. You whisper, "No way." But the numbers hold. The message, whatever it is, wasn't erased. It just moved into another medium. You stare at your monitor, the pulse line scrolling across the screen, and a thought crawls up from somewhere deep. Maybe data loss isn't sabotage. Maybe it's translation. Maybe the information didn't disappear. It changed form. The aurora outside your window flickers again, faint and low, colours bleeding through the clouds like ink in water. The pulse on your radio syncs with its rhythm. 3 beats, pause, 3 beats. The timing is too perfect to be coincidence. You grab your notebook and write. Data gaps consistent across systems. Mirror Song image equals real. Transmission may persist via magnetic field resonance. Maybe the sun is still writing. Then smaller. We're losing the evidence because we're not the intended audience. You close the notebook gently, as if afraid to startle the idea. The static on your radio fades into silence, replaced by the soft hum of the city's power grid. Somewhere above, those 25 newborn travellers keep their steady outward march, leaving a trail of vanished data and uneasy wonder behind them. You sit there in the dim light, realizing that forgetting can be as deliberate as memory, that perhaps the universe sometimes hides its own notes from us, trusting we'll rediscover them when we're ready to listen again. By the end of that strange week, you notice how quickly a planet adapts to mystery. The broadcasts slow, politicians move on, and the public begins folding the fleet into folklore, the same way people once folded eclipses into omens and comets into gossip. You hear schoolchildren on the subway singing a playground rhyme. 3 lights, 2 lights, gone through the sun. They giggle, not realizing they're repeating a pattern that once made the world hold its breath. You've stopped trying to track the outbound objects. The data gaps have grown like rust. Every orbital prediction diverges into nonsense after a few hours. Instead, you spend nights rereading your notes, tracing your own reactions. Wonder, fear, exhaustion, awe. They blur together until you can't tell which belong to you and which the story placed in your mouth. the first clear sign of what to call aftermath arrives quietly. One morning, an atmospheric physicist in Finland publishes a brief paper. Global measurements of background radiation show a small, steady dip, 1% below predicted solar output. The sun's brightness hasn't changed, but something in its spectrum has softened. Photons are missing in narrow bands, as if absorbed by an unseen filter. The report ends with a single line: further investigation required. You lean back, whispering, they left a fingerprint. A mainstream historical fact comes to mind. In 1987, astronomers detected the neutrino burst from supernova 1987A before its light reached us. Proof that invisible messengers travel faster than visible ones. Historians still argue whether that moment marked the birth of multi-messenger astronomy, or simply confirmed that light is slow to confess. Tonight you feel the same lesson stretching across your desk. Something happened at the sun, and light is still deciding how much to tell. The cooperative, reduced now to a few dozen diehards, treats the finished paper like holy scripture. One user overlays the missing wavelengths with the fleet's original pulse intervals. The alignment is unsettlingly neat. Another wonders if the sun itself has become a transmitter, humming at frequencies too deep for human ears. You find that thought comforting. You imagine the star as a giant archive, storing the event in radiation instead of memory. Every sunrise, the world bathes in the echo without noticing. Then a stranger writes to you, an astrophotographer from Kenya you've never met. She says her camera's CMOS sensor, damaged during the flare, now produces faint spirals of light when pointed at total darkness. She attaches an image. The pattern is unmistakable, the same curled geometry the fleet once drew across the sky. Maybe it burned into the optics, she writes, or maybe the optics remember better than we do. A fringe tidbit surfaces from an older journal. During the 1910 passage of Halley's Comet, early photographers reported ghost images of the comet appearing weeks later on reused glass plates. No chemical reason was ever found. The emulsion learned, one chemist joked. You smile at the echo, machines haunted by what they've witnessed. Historians still argue whether technology truly extends human senses or simply mirrors our longing to notice. Looking at that Kenyan image, you think, maybe both. That night you try the same experiment. You cover your lens, take a long exposure in total darkness. When the image renders, a faint trace curls through the noise, a thread of light looping inward, not bright enough to be certain, just enough to make you doubt certainty itself. You laugh softly. All right, you tell the universe. I'll take the hint. You post the picture to the cooperative. Replies pour in. Encouragement, disbelief, envy. A few others attempt it and find the same subtle curve, like a signature left on every sensor that once looked at the sun. The group begins calling it the afterimage. Meanwhile, official science moves on. New comets demand cataloguing, satellites need funding, missions to Mars resume their tidy schedules. The agencies have closed the file on 3 I/ATLAS, labelling it an anomalous interstellar object exhibiting temporary fragmentation. The phrase tastes like cardboard in your mouth. You print out the summary report anyway, pin it to your wall, and beneath it you tape your own handwritten addendum. Temporary fragmentation, permanent wonder. Then, because habit is a form of devotion, you turn the radio back on. The static is thin now, barely audible. But within it, if you listen long enough, you still catch that old rhythm. 3 pulses, 2 gaps, faint as breathing through snow. Maybe it's just the universe's background noise. Maybe it's the sound of departure. Outside, the auroras have faded completely, replaced by normal starlight. Yet when you stare long enough, you can almost convince yourself the stars are moving minutely, aligning into the same radial pattern the fleet left behind. You know it's your imagination, but imagination, you've learned, is just observation without proof. You open your notebook one last time tonight and write. Humanity handles mystery like heat. First we flinch, then we bask. The fleet is gone, the data is gone, but the pattern remains. Historians will call it an astronomical anomaly. I'll call it a rehearsal for listening. You close the book. The lamp hums. Somewhere deep in the electric walls of your apartment, faint interference crackles. 3 short pops, too long. For a heartbeat you swear the room brightens. Morning comes, slow and golden, And for once, the sunlight doesn't feel like interrogation. It seeps through your blinds like forgiveness. You've stopped checking the data every hour. There's nothing left to chase except the memory of the chase itself. Still, when your phone buzzes with an alert from the cooperative, you can't resist. The message reads simply, "They're out of range." No numbers, no graphs, no drama. Just that. The 25 outbound objects have faded below detection thresholds. Their reflected light has blended with the background sea of stars, their coordinates now approximations rather than certainties. You stare at the screen until the words blur, then close it. The story, it seems, has chosen its own ending, except endings are rarely that tidy. Later that day, a small observatory in India releases one last image, stacked from hundreds of long exposures, a farewell portrait of the solar system's edge. In the frame, faint trails curve away from the sun like hairs of gold caught in wind. It's beautiful and strangely intimate, like seeing fingerprints on glass. Beneath the image is a caption: "The fleet leaves nothing behind except direction." You sit with that sentence for a long time. A mainstream historical fact surfaces unbidden. In 1977, Voyager 1 launched into the dark carrying the golden record. Music, greetings, and sounds of Earth. It's still travelling, still whispering human presence into interstellar quiet. Historians still argue whether that gesture was humility or arrogance. You smile, realizing that the argument no longer matters. Voyager was our hello. The fleet might have been the universe's answer. News coverage dwindles. Algorithms lose interest. The auroras fade back into meteorology. The magnetic pulses into trivia. But small communities like yours persist. The cooperative becomes less about data and more about memory. Stories shared at 3 a.m., screenshots preserved like relics, the occasional reunion stream where people play back the heartbeat tone just to remember what awe sounded like. You learn to sleep again. When you dream, the sky above you is always bright, sometimes with fire, sometimes with silence. Months pass. One afternoon you receive a parcel with no return address. Inside, a thin glass plate etched with a pattern of spirals and faint lines. It looks handmade, maybe decorative, but when you tilt it toward the window, sunlight threads through the grooves, projecting the same geometry you once saw around 3i/80 LAS. There's a note folded beneath it, for the watchers, from Mirrorsong. You laugh aloud, half disbelief, half gratitude, and set the glass on your windowsill. Each morning after that, sunlight filters through it, painting slow-moving spirals across your wall. You don't tell anyone. Some souvenirs are better kept as personal myths. A quirky tidbit drifts from memory. In 1901, Nikola Tesla claimed he'd received radio signals from Mars. He was wrong, of course, but that single mistake inspired generations of dreamers to listen differently. You think about him now, alone with his static, convinced the universe was humming back, and realize you understand the feeling perfectly. Historians still argue whether belief precedes evidence or the other way around. Watching the sunlight swirl through your glass spiral, you decide it doesn't matter. Belief is just curiosity wearing hope as a disguise. Every so often, the radio on your shelf wakes itself, picking up faint interference, tiny, irregular pops. You've stopped analysing them. You simply let them play as background noise, a kind of cosmic ASMR. Sometimes, when the signal drifts low, it almost sounds like waves. The world moves forward. New missions, new crises, new jokes. But now and then, you catch people glancing skyward a little longer than before, as if waiting for another impossible visitor. Maybe that's the fleet's real legacy. Not proof, not technology, but posture. Humanity, head tilted upward, listening again. One evening you walk to a hill outside the city, telescope left behind on purpose. The air is cold enough to sting. Above you the stars burn steady. Somewhere out there, 25 tiny reflections of the sun are sliding into interstellar night, carrying with them fragments of whatever they learned here, about heat, about gravity, maybe about being noticed. You imagine them like seeds in dark soil, the universe their garden. A breeze lifts the edge of your jacket, you whisper, "If you're still listening, thank you for the lesson." The wind shifts, and for a heartbeat the static in your pocket radio clicks 3 times, pauses twice, then clicks again. You smile. Habitually you check your notebook, but for once you leave it closed. The page is full enough. Above you, The sky's enormous and kind. The sun dips. Its light softer than it used to be, or maybe you've just learned to see it differently. Either way, you feel smaller in the best possible way. You stand there until the first stars appear, until distance stops feeling like separation and starts feeling like invitation. Then you turn toward home, the spiral of light from your window waiting like a patient compass.